Interesting little sequences question for number 8. We've been given that un is 2 to the power of n, and in the first part we're doing something with un plus 1, so clearly that's just 2 to the n plus 1. And the question asks us to take these two things away, so 2 to the n plus 1 take away 2 to the power of n. Now, looking at that, you need to notice that this one here is just 2 times 2 to the power of n. You can see that because when we add the powers there, n plus 1 here. And so there is a factor here of 2 to the power of n in both of them. 2 of them here, take away 1 of them there, and that equals 2 to the power of n. And of course 2 to the power of n is equal to un. So there's the proof, although perhaps not as formal as it should be for part A. Part B, using that idea, u to the n plus m minus un. So same idea then, we've got 2 to the n plus m here minus 2 to the power of n. That is 2 to the m times by 2 to the n. In the same way I did 1 add n here, I'm doing m add n there. Factor out the 2 to the n, gives you 2 to the m, take away 1. And so we've got, I think that's what they wanted there, isn't it? So 2, yeah, that's it. So that's what they were asking for. So going back to part C now, we're going looking at the original sequence. So the original sequence, of course, is going 2 to the 1, 2 to the 2, 2 to the 3, and so on. So this is an increasing sequence. It's getting bigger and bigger and bigger. Certainly couldn't do a sum to infinity for this. But we can calculate the sum of the first 30 terms. This is going to be enormous. So it's a geometric progression. So we want the geometric progression formula, which is a 1 minus r to the n all over 1 minus r. A is the first term, which is 2. 1 minus, and the ratio you're timesing each time by 2. So I'm doing 2 to the power of 30 all over 1 take away 2. Well, that's just tapping that into the calculator it's a big number. 4, 8, 3, 6, 4, 6. Does it say round it at all? 2 significant figures. So 2 significant figures, it's big.